reduced the flow of the oil, at least then. And American and Dutch workers also built ponds in the desert to store all of that spilling oil so that they could try to recover it from being spilled. They also used booms and skimmers that were used to surround the areas that were impacted, especially near their desalination plants. So they were trying to protect the inflow of water during desalination at that time. Okay, so time for another quick break. So feel free to pause and then we'll continue. Okay, so what I wanted to show you here was some of the other consequences of the war. So as the Iraqi troops withdrew from Kuwait at the end of the first Gulf War, not only did they release oil, but they also set fire to over 650 oil wells and damaged many more of them. So what we're looking at here is the Landsat 5's thermal mapper, which shows Kuwait. So Kuwait is below the yellow line. The yellow line is the Iraq border, and Kuwait is south of that. So this is showing us in the left image is August 1990, before any of the fires occurred. The middle image is June 1991, and you can see the fires are burning at this point. And then on the right hand side, this is in January of 1992. So that was 2 months, or no, 2 months after the fires were put out. June, July, August, September, October, November, December, January. Yeah, so they burned for almost 6 months out there. So having pretty severe consequences on the air quality, actually. And some of the studies that came out during this time, they were really, giving a doomsday kind of opinion of how this was going to impact the global air quality and the global temperature. There were estimates, I think Carl Sagan actually gave estimates that the air, because of so much soot that would be going into the atmosphere, it would reduce the sunlight penetration and could actually spur a climate catastrophe, but it didn't end up being that way, really. So at the peak of the fires, the smoke absorbed about 75 to 80% of the sun's radiation. So it certainly blocked a lot of the sunlight reaching the surface of the earth at that point, at that location, obviously. And the particles rose to about 20,000 feet. It definitely affected weather patterns throughout the Persian Gulf and the surrounding region. And you can see here in this image the direction in which the trail of all of that soot is sort of, where it's going. So because this is in the wintertime, remember we talked about shamals and how shamals impact the weather there. This was during that time, and we can see the trails of smoke as the cold front is being pushed further south. So it's moving from Turkey down, and you can see the air masses that are moving from, it's moving southwest, if you get me. Right, so at this time as well, there was carbon soot rainout, or fallout it's called, which caused dramatic regional decreases in air quality. It was really quite a severe situation for Iraqis. They couldn't see sunlight for months, and people living near that fire were exposed to the soot as it was raining out of the sky. There was areas covered in black dust, and of course that led to respiratory problems for many of the Kuwaitis and those in neighbouring countries for many months after this had occurred. There were daily emissions as a result of these fires. So daily emissions of sulfur dioxide, which of course can generate acid rain, was about 57% of that from all electric utilities in the United States. So it was a severe amount of sulfur dioxide being put out into the environment. Estimates are that these fires created about 2% of global emissions for carbon dioxide at the time. and the emissions of soot reached about 3,400 metric tons per day. So an enormous amount of this disgusting soot that was created during these fires. Okay, so this is another video that I would like you guys to pause for a minute and go and find in the notes for slide 28 for a link to this video. It's a short clip, but this is actually talking about the Iraq oil fields that were burned in 2017, and it gives you, I think it's a Google, some of the Google images are on here, the 360 video, and it just goes through sort of what happened and why the fires were lit again. And yeah, it's pretty tragic, but do pause the video now and head to that link, and then when you're ready we'll continue. We only have a couple slides left. Okay, so we've talked a lot about you know, what causes oil spills and how it gets there, and the sort of the environmental disasters related to it, a couple of examples of that. But I wanted to just talk a little bit about the weathering process of oil spills. So what we have here on the right hand side is a figure showing you the different kinds of fates of oil once it gets into the environment, and I'll just go through and discuss each of those. So adsorption is when you have the oil particles cling to sediments, and then the sediments will eventually drop out of suspension, right? So oil can be dragged down into the depths through adsorption, or sedimentation it's called, and that effectively can remove it from the direct impact of it to wildlife, but it will also mean that it's just going to a different environment, right? So it's going into the deep sea rather than staying at the surface. Yeah, there's also some amount of biodegradation, and the next slide will go into that a little bit more in detail, but essentially it's the process of organisms consuming the oils and breaking it down into different components and degrading it that way. And dispersion, of course, is the other fate of the oil. So once it's at the surface, it's going to disperse out. And depending on, remember, we talked about density and viscosity, that will have a big impact on how much the oil is dispersed throughout the environment. Dissolution is also another piece to the puzzle, meaning it's going to come out of solution and dissolve into water. So there are different fractions of oil. Some of them are, you know, immiscible with water, meaning you can't mix it whatsoever. And then there are other fractions that are slightly more polar, and they will end up being able to be dissolved in the water just a little bit. So there'll be some of that which ends up being dissolved into the water and spread throughout the water column that way as well. Emulsification can occur as well when you have oil and water basically mixing and staying kind of as one liquid for a little while. If you make a salad dressing, for instance, you take the oil and you take the vinegar. When you put them in there and let them settle, there's very distinct layers, right? But if you take it and you shake it really vigorously, you'll get some of that oil to go into the vinegar, right? So you spread it onto your salad really quickly, and then that's how it works. So that's emulsification, just a short-term mixing of the two things that would not normally mix together. And evaporation also occurs as well. And for instance, during the Gulf War oil spill, they estimated about 50% of the oil that was spilled actually ended up being evaporated off into the environment as volatile compounds. So in terms of the environmental impact on land and water, the impact was a little less. It wasn't as dramatic as people were imagining, because so much of the oil ended up just evaporating. And then there's also photooxidation. So basically, once the oil is volatile and it's struck by UV radiation, it can oxidize and change its form as well into a different compound, and then gets dispersed into the air that way. So this is Pseudomonas, and Pseudomonas is a bacteria that is, quite good at actually consuming oil. And it's likely that these organisms evolved to consume oil because of natural seeps. So natural seeps have been occurring for as long as the planet has been around. And there was oil, of course. So not surprisingly, these organisms can metabolize the hydrocarbons and create different compounds that weren't as potent and toxic to the environment as the crude oil themselves. Okay, so that's all I have on that. Hopefully you guys were able to get to each of those links and have watched the videos. But if you have any questions, please do contact me. We've set up our office hours via Zoom, so take advantage of that if you would like. Those aren't mandatory, but you're more than welcome to log in and just chat with Dr. Eager and I about anything that we're going over. All right, so I will do another one of these and hopefully get it up pretty soon. So you guys have a good rest of the day.